Good afternoon. Hopefully your coffee break and snack break was refreshing, and hopefully I'll be able to keep you awake in this 4:30 p.m. slot talking about load testing. So, to start off, we're going to go through a few definitions. And yes, one of these things is not like the others. We'll go through what a load test is. We'll go through what a stress test is, the difference between a smoke test and a spike test and a soak test. Once we have the definitions down, we will take a look at exactly when you would even want to do one of these tests and what type of metrics, riffing a little bit off of Raphael's talk earlier today, what type of metrics you would want to collect based on the goals that you have on one of these load tests, because since it's going to take a fair amount of time and effort to build one that's actually representative, you want to have goals in mind. Next, we'll take a look at how to make sure that your load test actually represents some real-world, either planned or expected scenario, so that you aren't just merely doing a benchmark that you can paste on your homepage and saying, well, we serve this number of requests per second, and that doesn't actually matter. So, once we go through some of the pitfalls of, well, you need to make your load test more complex so that you can actually represent reality, we will take a look at a couple of tools to actually do the load test. We won't look at every single tool, but we'll look at one or two of them. And finally, as you're doing the load test, you're going to see bottlenecks in your system. So we'll go through, time permitting, a list of those bottlenecks so you can see what to look out for. That said, we don't have an infinite amount of time, so we're not going to go through every load testing piece of software out there, nor are we going to look at the clustered load testing solutions out there, because realistically, in most cases, you'll be able to generate enough load to properly test your system or maybe bring it offline through a single machine. And generally speaking, the non-clustered load testing solutions are a little bit easier to set up than the clustered ones. Likewise, we're not going to take a deep look into how to, say, load test from the bad end of a mobile connection, for example, if you're trying to use mobile broadband within this building. The key things to think about there, after which I'll move on to the next thing, is that those sorts of connections will take a little bit longer and use up a few more server resources, particularly if it's a slow connection and it takes a little while to download. The mitigation for that may be to compress data, but then you end up with potential additional resource usage, or even in certain cases, security issues that arise from compressing the wrong thing on, say, a secured connection. We're not going to get into that, but it's something to keep in mind. And let's see. We also will not take a look at deep per request application profiling. The answer to that question is usually something like Blackfire. So if you want to go deep into a single request, then you would use a completely different tool. You would not necessarily use a load testing tool. Finally, if you're trying to test a long-running process running on behalf of a single user, you may still fake up certain pieces of data and add them into the database, which you'll have to do for a load test anyway, but you don't need a dedicated load testing framework or dedicated load testing application in order to do that test. So, there are two tools that we will look at for actually performing these load tests. One of them will just take a very cursory glance at it because there's not a whole lot to it. And that tool, which you may or may not know of, is Siege. It's been around for a while. It is a bit of a standard in load testing tools, but you end up with a relatively limited set of functionality. So let's go ahead and start one of those tests. Okay, that is the system under test. Let's go to the tester. Perfect. So first, let's look at our script here. So in this case, I'm handing off a big old authentication token. I've already logged into this system under test, and I'm just going to hit that API over and over and over again on the me endpoint. Now, Siege does have a number of options, such as being able to iterate through a list of URLs to hit with load, and you can increase or decrease the amount of concurrent requests that you have, and you can increase or decrease the amount of time that's spent on a request. However, at the end of the day, you have a relatively limited set of things that you can do with Siege. That's why we're going to end up spending more of our time, at least on the implementation side, looking at the tool by load impact case 6, which is an open source package that it's actually written in Go, and it allows you to write your tests in JavaScript. Now, you might be wondering, okay, what is it doing with Go and JavaScript? Well, it's not actually using an engine like V8, so you write your JavaScript a little bit differently than you would in a standard, say, web app or a node app. So before I continue there, we've got results back from Siege here, and you know what? We've got a decent number of requests per second that this application can handle when loading the me endpoint, which is all well and good, I suppose, but realistically, we're not going to have a single user hitting their profile endpoint over and over and over again. Hopefully, our application is smart enough to cache the result of that endpoint anyway, which would invalidate the results of this test. But we'll get into those sorts of pitfalls later. So case 6, written in Go, you write your test in JavaScript. You actually use more of a blocking I/O, PHP-ish way of handling web requests. But you have a few niceties of, okay, it's written in JavaScript, so most anybody can write the test. And you have the ability to pull in, via Browserify, additional libraries to add functionality, which we'll actually see later in this presentation. So with all of that said, let's first talk about the system under test, because I had to have something to load test, and I had to have something that was, on the one hand, slow enough that I could show improvement by doing a couple of quick refactors, and quick enough to build so that it could be built for the first version of this presentation. So I picked a Laravel app. So you end up with, well, I like riding bikes, and I occasionally like going for runs. So I built this little fitness tracking thing of, well, if I wanted to do a minimum viable product of something like the Strava app or Map My Run, I want to have a set of activities. Each activity has a time and distance, and when that activity started. So you have a database of that, and then you have this lovely source of load called a leaderboard. And then you have on top of that challenges that if you participate in one of those challenges, it's over a certain set of dates, and it maybe has a distance or time goal. That gives us enough of an application that we can actually load test it. If we build the application in a naive way, then it will behave very slowly, and if we refactor it, it'll behave a little bit more quickly. That repo is on GitHub along with the load test script that you will see later. So let's go to definitions. First off, a load test is actually a specific case of a performance test. A load test is trying to go against your system such that it's representing peak load or maybe something below it. You're not actually trying to break your system with a load test. You're just trying to prove that the system behaves properly in response to an anticipated amount of load. If your system breaks, then you end up with a stress test. Now, a stress test may be due to a higher volume of requests than you expect your system would actually handle, or your system would actually get even at a peak time, or you might be simulating a loss of some of the resources that would normally be available to your application. For example, if the famously slightly less than reliable US East 1 region of Amazon Web Services decides that your auto-scaling isn't going to be so auto. So A stress test is going to probably break your application in some way. But that's fine. The point of a stress test is to figure out where your application bottlenecks are, and hopefully you've instrumented your application such that you can do that, resolve the bottlenecks, and then that same test won't end up being a stress test next time. So, in addition to load test versus stress test, I said, okay, well, we're going to talk about the difference between a soak test and a spike test. On the one hand, you have a soak test that you're load testing for a long period of time, which potentially in a cloud environment means that you're spending a fair amount of money doing a load test, so you want to make sure that it's actually valid and it's actually representative of real-world situations. But a soak test's idea is to make sure that your application can stand the test of time, can stand with a whole bunch of requests going at it, and not, for example, run out of disk space because you forgot to rotate your logs. On the other side of things, you have a spike test, where you're throwing a ton of load at your application all at once and seeing how it responds. Now, there are a few real-world use cases where a spike test is not necessarily too far-fetched from reality. There's a website in the US called Woot. They used to only have one deal per day, and now they're up to like a whole ton of deals per day. But when they started, it was a single sale per day, and that sale happened or started at midnight Central US time. So you would end up with a huge amount of load hitting their site almost all at once as people were refreshing the page to see what the new item was. So that actual use case, that actual usage pattern, would end up looking very much like a spike test in load testing. Likewise, if you have a big sporting event and you have a TV ad for that sporting event, and at the end of the ad you say, don't wait, go to www.wherever.wherever/ what the name of the offer is, congratulations, you just did a level of load on your system that is going to be best simulated by a spike test. As an example of that sort of TV side of things, Troy Hunt of Have I Been Pwned posted this screenshot on Twitter. Apparently, an Italian TV show had mentioned his site as a side note on how to protect your passwords, how to be notified when your password gets breached. And all of a sudden, he got a huge number of simultaneous users, real users, not bots, hitting his website. He was rather confused for a moment, and then somebody told him that an Italian TV show had mentioned him, and then the confusion was replaced by, well, I guess Azure functions scaled fine, so we were fine. So, one of these things is not like the others. A smoke test is merely a test to make sure that your application works well even at a single level of concurrency, a low level of load. Now, a smoke test may just consist of running your integration test suite once through and making sure that all parts of your application are exercised. Or it might be taking a load test, dialing it down to a single iteration on a single virtual user, which is just running through a single set of call this endpoint, wait, call this endpoint, and seeing whether the application breaks. Because if the application is going to give you 500 HTTP status codes on a single user, it's probably going to do the same thing when you throw 50 or 100 simultaneous users at it. So, in terms of metrics, you want kind of 3 S's on collecting information as a result of your load test. First off, you want speed. You want to see how quickly your application responds to requests. For those of you who were in Raphael's talk, he mentioned SLAs, SLOs, SLIs, of trying to make sure that your application responds within, say, 150 milliseconds on an API call. You also want to figure out how your application scales. You want to figure out its scalability. You want to see how many simultaneous requests go through the application and how many resources your servers use, whether that's on the web tier, the database tier, the queue tier, etc. And finally, you want to look at your stability, because your application may be super fast, maybe returning in single-digit milliseconds and having a really high level of concurrent requests for 502s and 503s. So, the time that you want to spend all this time and effort building a representative load test is when either your application changes or your load profile changes. On the application change side, you may be building a brand new app and you have some idea of how many people are going to assault your doors as soon as the application launches, so you want to simulate that load so that you are taking your site down before your users do. Or maybe it's adding a new feature, or maybe it's refactoring, maybe it's changing infrastructure such as swapping out a version of MySQL or adding some queuing service in, or some sizable infrastructure change. Maybe it's adding an index and wondering, well, did the index actually do any good? Or did I add too many indexes and now I have a penalty on writes and reads aren't any faster? You want to figure those things out in a controlled environment that isn't just shipping to production and hoping for the best. On the load profile side of things, if you are doing a new launch of an application or a feature in an application that you expect users to flock to, you're going to want to simulate those users before they flock to the site, because maybe, again, maybe you want that feature to actually go live and people to use it rather than bogging down your servers. Likewise, in the spike test situations that I mentioned earlier, you may have some level of promotion that external to your app, without any changes to features in the application per se, you're driving a fair amount of traffic to the application, and you want to make sure that that level of traffic that is driven is actually successful, meets your expectations in terms of metrics, rather than, again, erroring out. Now, those metrics that I mentioned earlier may vary in terms of what's acceptable between, say, a profile endpoint and maybe the leaderboard endpoint, or maybe an endpoint that creates a resource rather than one that merely views it. So, no hard and fast rules here. You'll need to talk with either the end users or people at least closer to them on your application to determine what your thresholds should be. So, you want to make sure that your tests actually represent some form of reality, either expected or actual. Now, you want to, instead of just testing a single endpoint, like I mentioned earlier with Siege, you want to test a flow of requests and responses, probably with wait times in between them, because realistically, people don't just merely click through a whole bunch of screens without reading what's on the screen. Likewise, you want to make sure that in your load test, and maybe you have a separate load test for these, you cover flows that happen often. You want to cover flows that maybe take a little bit more of a toll on your server resources. Maybe it's that leaderboard endpoint that you haven't gotten around to optimizing. And of course, you want to make sure that in your load test, your endpoints that you absolutely need to make sure that you're either delivering value to the customer and making at least them able to be convinced to pay you for your service or click your ads, make sure that those actually work. So, one potential trap when you're doing a test is to equate concurrent requests with concurrent users. There are a number of reasons where that isn't necessarily the case. First off, you have this concept of think time, because, as I mentioned, you're not going to click through indiscriminately through an entire website without reading through and gathering information along each step of the way. Even if you're autofilling a login page, there are still a few seconds of time between the point where you load that login page and the point where you hit submit. And then you have to go find your phone for the two-factor auth, and then you enter the code, and then you hit submit again, and then you're logged into your favorite service, and then you read something, and then you navigate. Each one of those think times decreases the ratio between concurrent requests and concurrent users. So being able to handle 50 concurrent requests on your API may mean that you can handle 500 concurrent users because the level of usage is relatively light. As another example, the slide software that I'm using to present this doesn't have to have API requests going back and forth the entire time. Yes, they have a WebSocket connection open, but they don't have to have a whole ton of requests going back and forth in order to make sure that I, as the user, have what I need to do this presentation. Likewise, if you're dealing with a single-page app or something that is primarily API-driven, you might see multiple requests coming from the same user, potentially to different endpoints, or maybe they are paging through results quickly enough that you have multiple requests to almost the same endpoint from the same user, from the same IP address at the same time. Finally, you could have caching happen either at the browser level because you set your cache headers correctly and it's not going to re-request the same data twice, or maybe it's very close to your application server. Maybe you're running Varnish or something to that effect. Or maybe it's somewhere in between. Maybe you have caching headers set such that a service like Cloudflare is saying, well, I already have this data. I don't need to round trip back to the origin server, which might be 300 milliseconds away, to get this data. All of your caching is going to reduce the load on your origin server for the same amount of traffic. So you might end up with having, say, 200 or 300 concurrent users not actually taking 2 or 3 times as much horsepower as 100 concurrent users. Again, we're getting into the realm of application optimization there, but just keep in mind that concurrent requests do not necessarily equal concurrent users, and that's why this concept of a virtual user, where you can actually step through a flow, is so important. So, there are a number of pitfalls to where you might oversimplify your system and have a load test that doesn't actually reflect any sort of reality. First off, who here has a system that they run in production that has a completely empty database? Yeah, you're probably going to have data in your database, and as a result, your database is going to perform differently than if it has an empty database and returns everything almost instantly because there's nothing to return. In fact, the shape of the data may determine what type of indexes get used on that database when calling out to see what a given object. So you want to seed your database with not only some sort of data, but realistic data so that the system works in a test scenario similar to the way that would work in production. And again, this becomes particularly important when load testing, where you're hitting multiple things simultaneously, and those, if you end up doing a query off index, then things get a little iffy. You also want to make sure to parameterize your input on a load test. So you may have seen in an earlier slide that with K6, you can take a browser trace, say, from Chrome as an HAR file and then plug it into a converter script, and then K6 will say, okay, well, here's a JavaScript blob that is going to perform the same actions on your server. That's not going to be parameterized, and as a result, you run it 5 times, you're going to get the same result every time. The issue with doing that in a load test is realistically you don't have a single user, you have probably a bunch of users. Each of those users is going to have a slightly different path through the system, and they're going to be looking up different keys in the database. For example, if you have one user hitting the same endpoints over and over again, then hopefully your application is smart enough to cache those endpoints, and as a result, you end up serving a whole lot more traffic than your application is actually capable of in a normal situation. You also need to take into account abandonment of the process at each stage. So you might, for example, have a user that tries to log in and they forgot their password, and they try to log in again, they still can't get their password, and they decide that they want to go elsewhere. You want to actually represent that flow, however often that flow happens, in your application so that you get proper parameters for your load test. Those users are going to generate less load than a user who actually successfully logs in and then starts interacting with a kind of full scenario on your application. So likewise, you may have input errors from your users. They're hitting the validation layer of your application and then bailing out because they maybe entered a password that wasn't strong enough on a user sign-up form. Those validation errors generally tend to happen early in the request lifecycle before you're doing some super heavy calculations. So you want to build those into your load tests as well so that, again, you're representing what users actually do. And again, you're going to get a few more user capacity points in your system by tracking those input failures in your load test. So on top of that, as I mentioned, you have think times. If you don't add your think times in, then you're going to wind up with a system that is able to run with an artificially low number of users because you're assuming that a user is going to hit an endpoint, then hit another one, then hit another one, then hit another one. And that's not a particularly realistic use case for an application that is being used by individual users rather than some cron job somewhere. Likewise, uniformly distributed think times or static think times are not an accurate representation of what an end user does either. You want to use some probabilistic distribution. Maybe that's the normal distribution. That's the one that we'll be using later on in these examples. But you end up with a kind of bell curve of the amount of time that a user takes in order to perform a given action. Now, there is still a bit of a pitfall on that because you may have different levels of expertise on users. You might have a user who is brand new to the system and as such has to read all of the help text and slowly fill through the form and maybe have an input error or two before they are able to get all the way through. Then you may have a normal user who doesn't need to read everything, but is not doing anything crazy like keyboard navigation through your entire site to load things as quickly as possible. And then you have your expert user on the other end of the bell curve, or maybe it's not even a bell curve because there is a completely different distribution of times that an expert user takes to interact with your system because they already know where everything is. They're going to click through as quickly as possible. So you end up with potentially having to overlay multiple distributions, multiple normal distributions, or maybe if you're dealing with how quickly people arrive to your site, an exponential distribution, to accurately reflect what an end user's experience of your site is going to be for your load testing scenario. So here's an example of, and this is a relatively simplified diagram, but we start over here, starting by authenticating, and we've got this nice little OAuth2 API there, and then 20% of the users don't get their password right the first time. So of those 20%, half or 10% of the total decide this isn't worth it, I will enter my fitness data later, and they leave. Another 10% try again. This time they get their password correct and are able to move on to the next step, which is making 3 simultaneous requests to their profile, their activity list, and the leaderboard for challenges to see where they stand on those particular events. And then some of those users decide, you know what, I want to set up a challenge of my own. So 5% of those users, after waiting around for 30 seconds with a standard deviation of 10 because it's a normal distribution, because people aren't going to wait exactly 30 seconds on that home page before they move somewhere else. They decide, okay, I'm going to create a challenge. And then some will say, okay, well, the reason that I actually opened the app was to record an activity. So after sitting at the main homepage for a little bit, they go in, they enter an activity. We assume that they enter all the information correctly because maybe we have client-side validation, so the input errors aren't going to propagate up to server-side. And then maybe they leave. Or maybe they say, well, I need to enter another activity, and they do that. Now, this is, as I just mentioned in the previous slide, a bit of an oversimplification, even this somewhat complex flow. But at least it gets us started and starts using some of these building blocks of distributions and probabilities and think times so we can get an idea of what a test script looks like. So, as part of this, you're going to want to have scenarios that represent different levels or kind of difficulty levels on your system. You might have a high-load situation where users are hitting more expensive endpoints multiple times because maybe your cache layer isn't caching, or maybe you misanticipated how many times people want to actually look up their leaderboard and say, oh, well, I'm now at the top of the list. Maybe you have your standard use case, and then you have your low-usage use case that's a little bit easier on your systems because there are more input validation failures, or you're just generally hitting lighter endpoints. So let's take a look and see what the actual script here looks like. So at the top here, we are importing a JavaScript probability library. We have to browserify it because this is not Node. This does not use NPM. It's just a little bit different way of pulling in dependencies, but you pull everything into a single file, and then you're fine. We're setting a whole bunch of parameters here in terms of probabilities of being able to log in, probability of abandoning on logout. Further down here, we're setting up the distributions of the think times for how long a user is staying on a given page. Further down, in the name of parameterizing as much as we can, we're actually varying the dates and times and distances and such that are being entered into the activities screens so that we don't end up with a clump of data that distorts the way that the database indexes things. Now that we've set all those variables, we can actually call through, and this export default function is what the virtual user actually runs on each run through. So we make a request here. We might log in, we might not. If we don't log in, maybe we re-request, maybe we don't. We continue through here. We call a few endpoints simultaneously, get those results back, and the interesting thing that K6 does is it markets itself as unit testing for performance. So we can actually check to make sure that our responses actually return the correct status code and actually have what we expect in the response body. Going further down here, we say, okay, well, we're at the probability level where we want to create an activity or a challenge, and we decide what values to enter, and we make those calls. And along the way, we keep on checking to make sure that, that we get back from the API what we expect. Likewise, we start keeping track of trends in the data to see, okay, on average, actually don't use average, I'll go into that in a little bit, but what time distribution is it taking in order to fulfill a request on one of these endpoints? So that's a fair-sized script in order to get just those few boxes in that previous diagram built out. But you can be very specific in this script so that you can try your best to represent what an actual user flow would be on your system. So load testing tools have strengths and weaknesses. In the case of K6, one of the weaknesses currently that they're actually working on, there's a PR that the latest commit on was about 3 days ago, is the ability to have arrival rate-based simulation. And the reason that that's important is in a virtual user-based simulation, like the one that we're talking about here, when a user goes through a flow, they finish, they go through it again, maybe with different variables, they finish, they go through it again. If the server responds slowly to that user flow, then it will actually decrease the amount of load that's on the server because it's a set number of virtual users going through the motions. If you have an arrival rate-based system where on every second or every minute or however you want to do it, a certain number of users enter the system and start going through the process, then you don't end up with the system under test being able to have back pressure back on the load testing system and actually slow the load testing system down. This is another piece where the tooling will either allow you to or get in the way of being the most accurate test possible. So, on top of that, you want to make sure that you are as accurately representing your production environment as possible when doing these tests. That means that you want to have logging. That means you want to have metrics. For one reason, you want to make sure that if you're going to run out of log space in real life, then you run out of log space in your test environment, and then you fix that. And also because you want to ensure that you actually get valuable information out of your load tests so that if there is a problem, then you're able to fix it. Likewise, application performance monitoring systems like New Relic and Tideways should be turned on in your test environment if they're turned on in production. You'll see the same performance hit between testing and production that way, so your test environment isn't unrealistically fast at handling requests. And also, you'll get a whole bunch of valuable data to see where bottlenecks are if they do exist in a way that causes you to miss your expectations on your metrics. So, on top of this, you want to, if you have infrastructure as code, for example, Terraform or CloudFormation, if you're doing a Amazon stack or something to that effect, then you can build up an environment that is piece for piece nearly identical. Okay, maybe it's some third-party API is a little bit different because you're using a sandbox rather than the real thing, but nearly identical, if not identical, to your production environment, which means you have a whole lot more confidence in being able to test in one environment and have those results and those conclusions apply to the other. If you don't have infrastructure as code, maybe you can get close with containerization, maybe a build book or something like that, but each piece of that is going to make setting up a proper test environment more difficult. And if you have infrastructure as code set up and you're running on a cloud environment, then you can build up an entire load test environment, run for an hour, maybe two, or maybe for a short period of time, tear it down, and maybe your cloud provider bills per second or per minute. So your load tests tend to be more expensive in the amount of time that it takes a developer to build them than the amount of hardware that it takes to actually run them. So likewise, the one thing that I mentioned early in this presentation was that I'm not going to go into a heavy amount of detail on testing from 300 milliseconds away over a slow 3G connection or something to that effect. That will have some impact on the way that your system performs if, for example, you ran out of connections because your web server, your load balancer, hasn't finished draining connections from those slow users. It's something to keep in mind. Maybe your system is architected such that that's not the bottleneck, that doesn't matter, but it is certainly a question to bring up. And finally, you want to make sure that the auto-scaling facilities or load shedding facilities, if you turn off certain features in levels of high load, are actually represented as well in your test bed unless, of course, you're trying to do a stress test with the assumption that auto-scaling isn't working, in which case, make sure that that assumption is explicit, rather than just saying, well, we don't have auto-scaling in our test environment, and that's just the way it is, even though our auto-scaling in a production environment would make a certain test result invalid because, well, we're able to scale our way out of the problem before it actually happens. So, I said earlier that you probably don't want to look at averages in your test results because averages tend to wash out all of the detail in clustering or just the specifics of a given data set that you're going to get back. Whereas median or 50th percentile, 90th and 99th percentile will give you a better idea of how your system performs most of the time, or really most of the time, rather than saying, well, here's a smudgy version of a number that doesn't necessarily mean anything. Now, you might be wondering, well, what about 99.9th percentile? At that point, does it stop mattering what requests are at or above that threshold? And well, if you're dealing with a single-page app or something that's relatively API heavy, that's maybe making 10 requests to the API, then all of a sudden, you go from a 99th percentile response on one request, only happening 1% of the time, to out of, say, those 10 requests, you've got about a 9.6% chance that one of those requests will actually be in the 99th percentile. So you want to keep track of those numbers maybe a little bit more carefully than you would otherwise. So finally, you want to make sure that if you have an outlier of some sort, you explain it. If you have, for example, a bell curve of results here and your 99th percentile is over here, and then you have a whole chunk of results that are really fast for some reason, there might be a few explanations for that. You're going to want to look at the response codes that come back and any headers that come back because maybe those responses came from the cache because maybe you didn't do a good enough job of parameterizing your data set, or maybe the cache is doing what it's supposed to do in reducing the amount of load on your application servers. Or maybe you want to check that response code because those responses are 404s or 502s. And the key here is that you don't want to discount a certain cluster of outliers or a certain outlier in the results that you get back just because that might be inconvenient to look up what exactly that's doing. So let's go ahead and do another test here. And this time we'll run with case 6. Okay, that's the system under test. Close this. So, case 6 actually operates as, since it's written in Go, it can operate as a single binary. The way I'm running it right now is inside a Docker container. And I'm actually running it inside Docker Compose because case 6 allows you to push results to a number of locations for additional analysis. That result location might be Load Impact's own visual dashboard for these things, or you can actually use it with a complete set of open source tools like InfluxDB in Grafana. While I'm showing the InfluxDB in Grafana bits, we'll run this. You'll see here, though, that we have a few assertions that we're making as part of this test, and they actually all passed, and that's all well and good, although we have, kind of taking forever for the service to load that challenge page. So, while we're doing that, let's open up Grafana here. And this is one of the nice things about the Docker Compose version of pulling down K6 and running it, because it's a very quick setup to get this dashboard of graphing your various response times and seeing averages in 90th percentile and that sort of thing in a format that is more detailed and prettier than that text output. So one thing to note on bottlenecks is you may have a whole bunch of requests that in and of themselves are relatively light, not a big deal, but taking an aggregate are actually the lion's share of all of the all the resources that your server is using. And on top of that, as your system gets closer to reaching capacity, there are going to be the one-off requests that actually exceed the system capacity for a fraction of a second and cause a cascade of errors and slowness and maybe downtime as a result. So as you go from load testing territory to stress testing territory, I would 100% expect that certain request and response times go up by maybe an order of magnitude. So I know we're running a little short on time here, so the slides for this are available online, and as a result, I'll kind of gloss over some of these bottlenecks. But you need to keep track of the various services that are running in your system and watch for each kind of unique set of bottlenecks that are in that part of service. Maybe you run out of FPM workers. Maybe your server is CPU bound. Maybe you run out of memory. Maybe your queue has so much queue depth that maybe you're running your queue on Redis, and maybe your Redis queue runs out of memory, and then you're also using Redis for a cache, and now your cache gets cache eviction because you ran out of cache to use, and now you're trying to prime that cache with about 50 requests simultaneously, and you get a thundering herd problem, and then everything catches on fire. Or maybe your database is CPU or I/O bound, or maybe some in-database cache fills, and you revert to solving queries the slow way. Or maybe your load balancer runs out of connections. Or maybe your external services have an API limit, whether that's an actual API limit where you get a nice error code back saying that you ran out of requests, or maybe their system actually hasn't been tested under load and they fall over, so you end up with request timeouts or inordinately long responses. In all these cases, you want to keep track of, yes, going back to Raphael's talk, a very detailed set of metrics as you're doing these load tests to make sure that as you see one of these bottlenecks, you know exactly where it is, so you can go back and resolve that. So we'll look back. Okay, so in this case, this is prior to a set of optimizations that I did on this particular package. So we're actually seeing a whole bunch of timeouts on that expensive endpoint rather than actually completing the request. And it's no fault of the provider that I'm running this on. It's just because I wrote some bad code. So while I am running a test with some fixes on it, which the fixes are listed on GitHub and linked from these slides, I believe we can go ahead and open it up for questions while I run the second run. We can use Slido for that, by the way. So while that is running here, again, these highlighted links are to fixes for those bottlenecks. And beyond that, I've got a couple of slides that go into a few other options that are all free and or open source for load testing, depending on what exactly your system or what exactly your goals are for load testing. And certain things are better at certain types of tests. But that is a slide that I intentionally had in here so that you can look back at that resource later. So, as mentioned, that concludes this talk, and while the test is running in the background, I'll take questions.
Okay, yeah, we have, I think, 4 questions through Slido. So the first one is, what are your thoughts about the AB tool?
Apache Bench. I used it a bit, and I actually have it. I think I have it listed. Yeah, it is in this list, but because there wasn't a ton of difference between the level of detail that you could get with Apache Bench versus Siege, I didn't go a whole lot into researching that because they're basically 2 big families of load testing tools. Your more complex ones that allow you to be very specific with kind of scripting out your load test, and the more simple ones where it's just kind of hit an endpoint over and over again. And since I was already using kind of Siege as an example of the more simple one, I did not look very carefully at Apache Bench.
Okay. And then how about stress testing by using staging environment and replaying on it access logs from production plus adding concurrency to simulate heavier load?
Let's see if I get my understanding of the question correctly. But a staging environment is an excellent way to do that stress testing, and trying to get as close to the production environment as possible, whether that is by keeping logs there or something to that effect, certainly sounds like you're trying and potentially succeeding at having a more representative way to load test. You don't necessarily need a clean from scratch environment to do a load test in.
Okay, and how about integrating load tests into CI?
So I would say that integrating into CI is, because load tests tend to be a bit more expensive to do and tend to take longer to get results back, you might want to do like a load test in a nightly build. If you have your infrastructure as code and you can spin it up and then spin it down, then there's certainly a place for including it in your CI suite, but you very, very likely would not want to run it on every build, because due to the nature of load testing, things could get rather expensive rather quickly.
Okay. Can you shed a bit more light on the whole workflow, how we would test for live app?
So for testing a live application, again, the first step is to make sure you have an environment that is not production, because one of the reasons that you're doing the load test is to make sure that if you have an anticipated or above anticipated amount of load, that any bottlenecks get surfaced in an environment where it's safe to do so. Once you have a non-production environment, you can use, for example, you would build out your load test maybe based on application logs from your actual production servers to say, okay, here are the types of requests that we're seeing, here's how often they happen, here's the flow that users use to go through the application. You build your test to replicate that flow or your expected flow, and then you tell your testing suite, all right, let's throw a certain number of virtual users at the system following that flow, and either test to the expected amount of users if you're doing a load test, or increase that number of users until something breaks in the case of the stress test.
Okay. What's a good way to manage the alpha tokens in load tests in environments where they expire after a short time?
So the best way to handle that, and the way that I actually did it in the K6 side of things, is to simulate the login process as part of the load test. So if you go through the load testing script on the K6 side, you'll see that the first step in that process is to log in. Now, of course, you have your OAuth client ID and secret in there. My assumption is that those don't roll over very often. But the actual authentication tokens themselves are generated as part of an iteration on that virtual user, because realistically, your users are going to be signing into your application as part of that. So testing that sign-in flow is an important part of the load test. And that is one detriment of a tool like Siege, because you can't really take an initial stage of a load test and then feed it into the next thing.
Okay, and the final one, would you say that it makes sense to test with a larger data set than you have in production?
Yes. Keeping in mind that you might end up in that case with erring on the side of a stress test, but if you're trying to test for anticipated load, for example, on a case where you're doing a promotion and there are going to be more users signing up in the database anyway, then it is a completely valid case to say, let's put more data into the database than we possibly have. For example, in the scenario that I worked with here, I actually used Faker to build out a set of a whole bunch of users, a whole bunch of challenges, a whole bunch of activities, because I'm just one person and I didn't want to go through that manually. So there's actually a significant amount of stuff in the database that's being tested against on this load test, and that's why that leaderboard endpoint is taking so long to render without optimizations at the database level.
Okay, thank you, Ian. Can we hear it for Ian Littman?